Once the system is in operational use, it'll be used within its external environment to close that capability gap that defined the need for the system in the first place. Support will also be provided to the system. It's common to think of support in some form of hierarchy. In this MOOC, we've used the words operational, maintenance, and engineering support to describe this hierarchy. Let's use our house example to explain. When you live in a house, there's always something that needs to be done. We sweep the floors, we clean the bathrooms, we keep the spiders' webs away. We might even need to change the odd light bulb or the odd washer in a dripping tap. These are activities that we expect users to be able to look after in order to keep our house running smoothly. And these are examples of operational support activities. In the longer term, we might need to repaint our deck every year to protect it from the weather, and we might need to clean the gutters every autumn. We would consider these routine or preventative tasks to be examples of maintenance support. Sometimes we would need to get an expert for things like electrical problems or sewage blockages. Even though we need external help with these issues, they are still maintenance activities because we're not changing anything about the house, we're simply maintaining it. Sometimes though, we need deeper support, and we've called this category engineering support because the deeper support often involves making changes or upgrades to the system. Engineering support needs to be established with the system. It's not something that we can assume will be in place automatically. Ensuring all of our engineering and design documentation is correct during the detailed design and construction and production phases will be an important part of enabling engineering support into the future. This leads us on to a discussion about modifications. Modifications to our systems during the utilisation phase are almost inevitable. Users will suggest new requirements. Our environment will change. Technology will change, causing us to address obsolescence and enhance supportability. Sometimes modifications are also required to address issues that were uncovered during the testing process. Modifications are like a reinvigoration of the system's engineering process. A modification is like a mini systems engineering process all over again, where we have a complex problem that needs to be understood, solved, and implemented. Where possible, we should try to build expandability and upgradability into our systems to support future growth and modifications. Some examples in a house might include a house being designed for a small family with the expectation that children will follow and the house will need to be extended. Another example might be a house being designed to allow the addition of autonomous accommodation for an ageing relative in the future, or anticipating that our carport might one day become a lock-up garage with a workshop and a shower. If we take into account these possibilities during the design and construction phase, we will have much more flexibility in incorporating these upgrades in a cost-effective fashion in the future.
If you're interested in reading further into the topics we covered in this presentation, you may wish to read the corresponding chapters in the texts associated with the course.